Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P2A00, indicates an air-fuel (AF) sensor circuit range or performance problem specifically related to sensor 1, which is crucial for optimizing the engine's air-fuel mixture for efficient combustion and emissions control. This sensor plays a vital role in maintaining the right balance of air and fuel entering the engine, and it is typically located before the catalytic converter in the exhaust system, near the engine's cylinder head. By monitoring the oxygen levels in the exhaust gases, the AF sensor provides vital feedback to the Engine Control Module, ECM, or Powertrain Control Module, PCM, adjusting fuel delivery and timing based on real-time conditions. If the circuit performance is off, it can lead to increased fuel consumption, poor engine performance, and elevated emissions. Before troubleshooting, it is recommended to record all freeze data and any onboard snapshot for better diagnostics. Additionally, a review of general troubleshooting information can provide insights into similar issues that may arise. The DTC P2A00 specifically denotes an issue with the air-fuel AF sensor 1 circuit. This sensor is pivotal as it helps the engine maintain an ideal air-fuel mixture necessary for efficient combustion. It is integrated into the exhaust system, generally located near the exhaust manifold or cylinder head. When the engine expels exhaust gases, this sensor measures the concentration of oxygen present and communicates that data to the Engine Control Module, ECM, or Powertrain Control Module, PCM. This feedback enables the ECM-PCM to make precise adjustments to fuel delivery and ignition timing, ensuring optimal engine performance and emissions compliance. A malfunction in this sensor can lead to incorrect data being supplied to the ECM-PCM, resulting in various performance issues, including poor fuel economy and increased emissions. Several potential causes could trigger DTC P2A00. A likely culprit is a faulty air-fuel AF sensor 1, which may provide erratic readings or fail entirely, affecting the ECM-PCM's ability to regulate fuel and air properly. Wiring issues can also arise. Damaged, frayed, or corroded wires could disrupt the communication between the sensor and the ECM-PCM. This is important to note, since electrical connections are key to how accurately the sensor operates. In some cases, the ECM or PCM itself could be malfunctioning, not processing the sensor inputs correctly, or failing to control fuel delivery. It's crucial to methodically examine all these possible causes to pinpoint the root of the performance problem indicated by this DTC. Several symptoms may arise from the DTC P2A00, each indicating issues with the engine's operation. One of the most noticeable symptoms is poor fuel economy, as an improper air-fuel ratio can lead to excessive fuel consumption. Drivers may also experience a rough engine idle, where the vehicle shakes more than usual when stationary, suggesting that the combustion process is not functioning smoothly. Additionally, increased emissions can result from an incorrect mixture of air and fuel, which can trigger the check engine light and fail emission tests. Other possible symptoms may include performance hesitations during acceleration or a reduction in power. Understanding these symptoms help in diagnosing and addressing the malfunction sooner rather than later. In the first troubleshooting step for resolving DTC P2A00, the ignition should be turned to on position 2 to power up the vehicle's electrical systems, including the Engine Control Module, ECM, and HDS, or Honda Diagnostic System. Once the ignition is on, clear the DTC using the HDS. This action resets any stored trouble codes in the ECU, Engine Control Unit, allowing for a fresh test. Following this, start the engine and maintain the engine speed at 3,000 RPM without any load. This means having the automatic transmission in park or neutral, or the manual transmission in neutral. Holding this RPM ensures that the vehicle can reach the necessary operating conditions to initiate diagnostics effectively, and allows the radiator fan to activate, further stabilizing engine temperature for the upcoming tests. In Step 2 of the troubleshooting process, it's essential to test drive the vehicle under specific conditions to pinpoint any remaining issues that might not have appeared in idle tests. The engine coolant temperature, monitored by the Engine Coolant Temperature ECT Sensor 1, must be above 158 degrees Fahrenheit, 70 degrees Celsius, which ensures that the engine has reached a warm operating state. During this drive, maintain a vehicle speed between 25 to 55 miles per hour, 40 to 88 kilometers per hour, for at least 5 minutes. This speed range allows the AF sensor to operate correctly because it is working in a typical performance scenario, collecting real-time data about the air-fuel mixture under load. Following this, the vehicle should accelerate to a steady speed between 55 to 75 miles per hour, 88 to 120 kilometers per hour, for approximately 10 seconds before closing the throttle and allowing the vehicle to decelerate for 5 seconds. This sequence aids in validating the sensor's performance under varied driving conditions. The third step involves monitoring the onboard diagnostic OBD status using the HDS. This device provides essential data regarding the performance of various vehicle modules, including the AF sensor. You must check specifically for DTC P2A00 in the DTCs menu to see if it appears as failed or passed. If the HDS indicates that the DTC has passed, the AF sensor appears to be functioning correctly at that moment. However, if it shows failed, there may still be a real issue that requires further investigation. It is also crucial to note if the HDS indicates executing, meaning the system is actively monitoring performance, in which case you should continue driving until a definitive result appears. If indicated as out of condition or not completed, you should return to Step 2 and recheck the vehicle conditions. Once the HDS indicates a failed status for DTC P2A00, it's necessary to turn the ignition switch to lock 0 to ensure safety while working on the vehicle. At this stage, replacing the AF sensor 1 is advisable, as it is usually the component associated with errors of this nature. When removing the old sensor, take care to disconnect any electrical connections properly and follow the manufacturer's guidelines for installing the new sensor. After the new sensor is in place, turn the ignition switch back to the on position, I, to reinitiate the vehicle's electrical systems and prepare for reprogramming the ECM/PCM, which is essential after any sensor replacement. The fifth step requires resetting the engine control module, ECM, or powertrain control module, PCM, using the HDS. This reset is crucial because it clears any previous stored parameters related to the old AF sensor. Following the reset, performing an idle learn procedure is vital, as it recalibrates the idle speed control parameters for the new sensor. Once these processes are complete, you will need to conduct another test drive under the same specified conditions as before to verify the sensor's functionality and to ensure the engine is operating optimally. This secondary test helps validate whether the replacement has resolved the DTC P2A00 issue and enables you to obtain new diagnostic readings. In the sixth step of troubleshooting, you will again check for pending or confirmed DTCs using the HDS after you have completed the reset and test drive. Look specifically for DTC P2A00. If the code is indicated once more, it may suggest an underlying issue with either the newly installed AF sensor or the connections leading to the ECM/PCM. In such cases, it is essential to investigate the wiring and electrical connections closely for any signs of damage, corrosion, or loose terminals. Any inconsistencies here could lead to repeated codes despite replacing the sensor. If no issues are found and the DTC does not reappear, proceed to the next step for final confirmation. Finally, in the last troubleshooting step, monitor the onboard diagnostic (OBD) status once again with the HDS. It's imperative to specifically review the status for DTC P2A00. If the HDS indicates a status of passed, this shows that the system is functioning optimally after the replacement of the air-fuel sensor 1, completing the troubleshooting process. If other pending or confirmed DTCs were indicated in Step 6, then those should be addressed as needed. Alternatively, if the HDS still indicates failed, escalate the checks for poor connections or loose terminals at both the AF sensor and the ECM/PCM, repeating the earlier steps for thorough inspection. This final check is crucial to ensure all components are correctly operational before concluding repairs. Once troubleshooting and repairs are complete, the final stage is to verify that the DTC P2A00 is indeed cleared and that the vehicle operates as expected. You can confirm this by running another diagnostic with the HDS to ensure that no fault codes are present. Additionally, it's vital to evaluate the overall performance of the vehicle to ensure smooth idling, good throttle response, and optimal fuel economy. These factors are key indicators that the corrective measures have been successful. Furthermore, ensuring customer satisfaction is critical. This might involve explaining the repairs made and providing guidance on vehicle care to prevent similar issues in the future. A thorough wrap-up not only assures the customer of the quality of work, but also builds trust in your service. Preventive maintenance is fundamental to minimize the recurrence of DTC P2A00 or similar issues in the future. Regular checks of the air-fuel sensor 1 can vastly reduce risks, allowing mechanics to catch early signs of wear or malfunction before a code is triggered. Additionally, routinely inspecting the wiring conditions, including looking for frays, corrosion, or loose connections, ensures that the electrical systems involved in engine management remain intact. Furthermore, keeping the engine coolant system efficient is crucial, as extreme temperatures can lead to sensor malfunctions and ultimately impact engine performance. Keeping filters and fluids clean and replacing worn components proactively will create a more reliable vehicle and enhance overall efficiency. In conclusion, understanding the air-fuel sensor's role and its significance within the engine's operation is vital for effective troubleshooting of DTC P2A00. A systematic approach, following the precise diagnostic steps, allows for thorough evaluations to identify issues efficiently. This methodical troubleshooting process, in tandem with properly replacing faulty components, can lead to successful resolution of performance problems. Moreover, recognizing the importance of preventive maintenance cannot be overstated. Consistent checks and timely replacements can often negate major issues before they arise. Ultimately, a combination of diligence in diagnostics and a proactive maintenance strategy is key to ensuring the longevity and efficiency of the vehicle. Please like and subscribe to the channel. See you next time.